James Webb was NASA's second administrator, and he led the agency during the 1960s, that key space race period. He oversaw the development of the Mercury, Gemini, and eventually the Apollo program that culminated with us landing on the moon. So in this amazing photograph, we're looking at light that left these galaxies 13 billion years ago. And it took that long to travel from those galaxies to our eyes, or to the sensor on James Webb. So we think of light in our everyday lives as being basically instantaneous. And it is really, 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 really fast. But it does travel at a fixed speed, the speed of light. And over the enormous distances in the universe, it can actually take quite a long time to get from one place to the other. And this is all complicated by the fact that since that light left those galaxies billions of years ago, the universe has actually been expanding. And so not only are those things really far away to start with, but the space that they've had to travel through has gotten longer and longer and longer. And so what we're seeing is what those galaxies looked like when that light left it. Most or maybe all of those galaxies are now gone, but we're seeing this beautiful snapshot of what the universe looked like basically when it started. The universe is just so incredibly big. Take your pinky and hold it out sort of at arm's length, and especially if you're by a window or something, look at it against the sky. Then imagine taking a single grain of sand and sitting it right there on your pinky. That's the amount of space on the sky that James Webb was looking at when it took that photograph. Now kind of look around and see how many of those pinkies or those grains of sand would it take to cover the entire sky. It'd be thousands, if not millions. And that tells us that even in this one little tiny fleck of space, we see hundreds or thousands of galaxies. Just imagine how many are out there across the entire sky. James Webb is located about 1.5 million kilometers, or about 1 million miles from Earth. It's actually outside the orbit of the Earth at this special gravitational point called L2. And that's a really handy place for James Webb to be, because it means that at all times, both Earth and the sun are in the same part of the sky. And that means that it has the whole rest of the sky to look at, rather than, say, the Hubble Space Telescope, which is very close to Earth. And so Earth is blocking out a huge fraction of the sky at any given moment. James Webb is the next generation of NASA's space telescopes, and we're all familiar with Hubble. It launched in 1990 and has taken millions of beautiful pictures that have just wowed us all over the last 30 years. But James Webb is a step up from Hubble in almost every way. So it's a lot bigger. It collects about 6 times more light than Hubble. And that means that it can see objects that are much, much fainter, which allows us to look back even farther into the universe. And importantly, it observes the universe in infrared light, as opposed to Hubble, which looked at the universe in visible or ultraviolet light. And so that lets astronomers explore space in a different slice of the light spectrum, but it also has some important advantages. Infrared can see through the dust that's in the universe, so that's going to allow James Webb to look at places in space that were obscured to Hubble because of all the dust that's out there in space. And then it turns out that planets also emit mostly in the infrared. And so one of James Webb's big targets is to look for planets that might support life around other stars. And the best way to do that is to look at the atmospheres of those planets, which shine really brightly in the infrared. These photographs are just incredible, and they're the culmination of decades of work to make this possible. James Webb, by some measures, is maybe the most complicated, most precise scientific experiment that we've ever conducted. And to get the most out of it, we had to put it really far away from Earth, a place where astronauts could never go and fix it. And so NASA took a huge gamble to make these pictures possible. And what we're seeing today is that it's worked. Every piece of the process has worked exactly as planned. And now scientists can look forward to more than a decade of understanding the universe with this incredible instrument.